So now we're going to talk about procedure calls. And this is a very important part of any programming, and so we have to be able to make sure that we can handle it on our architecture. So procedure calls, these are functions or subroutines, are needed for any sort of structured programming. If you look at an example of the program we have here, we have a main function, and that main function is going to call another function or another subroutine, this update function. And there are a bunch of things we need to be able to do here. We need to make sure we can call this without messing up what's going on in main. And what's important to keep in mind here is that this is not a procedure that's in your code. Somebody else might have written update. It might be in a library or in another file. So you don't control the implementation of this. And so this has some interesting implications. If update, for example, writes into a register, we need to make sure that that register doesn't overwrite data that main is using. So we need to figure out a way to be able to call procedures or functions without messing up what's going on in the main function. So there are a few things we need to do in order to make this work. We need to find a way to put the data where the procedure can access it. So if we look at this procedure, we can see it has two inputs here, A of j and j, and we need to figure out how can we put this data here such that the update procedure can access them. Then we need to start executing update. We need a way to jump to it so we can run that code. Then it's going to do work, and it's going to use registers, and then we're going to return to the caller. So after update here is done, we need to make sure that we can jump back into the code where we left off. We need to get those results back. So update's going to change some data. How do we make sure that the main program knows what data has been changed? And most importantly, we need to be able to do all of this without messing up the caller's registers. So if you look at what's going on here, this code up here, these for loops, these are going to use some registers in the processor, and whatever happens inside of update is going to use registers in the processor. And we need to make sure that the registers used here don't mess up the registers used back here. So let's look at this more specifically. So here's the same code we had before, and we're going to make some definitions. We're going to call the main function here the caller. It's the function that's going to call the procedure. We're going to call the update procedure the callee. It's the procedure that gets called. The callee has some parameters. Those are the inputs to it, in this case A of j and j, and it generates some results. And I'm going to try and be consistent with the color coding here so you'll know what I'm referring to. So specifically, what do we need to do? We need to put the parameters in a place where the callee can get them. So that is, the data that the caller, main, wants to send to update needs to be put somewhere where update knows how to get at it. We then need to transfer control to the callee. We need to jump into the callee procedure so it can begin to run. Once we're inside the callee procedure, we need to use the registers to run the callee procedure. So this update here is going to do something. It's going to use registers, and we need to be able to use those registers. We need to execute the code, so update's going to do something. We need to do whatever it does. Then we need to place the results of the procedure in a place where the caller can access them. So we need to take the results from update, and we need to put them somewhere where the main procedure, the caller here, can access them. In this case, it's A of j. And finally, we need to return control to where we were before we did the call. So we need to go back to wherever it was we left off in main so that we can continue on the next instruction in main. And again, we need to do this without messing up the caller's registers. So main is going to use a bunch of registers, update is going to use a bunch of registers, and we need to make sure that update doesn't write over main's registers. So let's talk a little about a caller context. So here's an example procedure. So we've got a function of g, h, I, and j, which is going to do the same thing we've been looking at before. It's going to do g plus h minus I plus j, and here's the code for executing it. What we have here is a caller, like main, and if that caller is using R1, R2, or R3, they need to be saved. And the reason they need to be saved is because the callee overwrites them. If we look at this procedure here, you see that this procedure, the callee, is going to write data into registers 1, 2, and 3. So if the caller is using registers 1, 2, and 3, we need to make sure somebody saves those because the callee is going to overwrite them. So this is what we need to do. We need to make sure that the context doesn't mess up, that the registers that the caller is using are preserved after we make the call to the callee. So there are two problems that we need to look at here. The first one is the callee does not know which registers the caller is using. So the procedure here doesn't have any idea which registers main is using. There could be multiple different mains that call the same procedure, so we have no way of knowing which registers are being used. Also, the caller doesn't know which registers the callee will use. The callee, or the procedure, could have other procedures that it calls. So when we call update, update could also call read or write or update part, and all of those could use other registers. So neither the caller nor the callee knows which registers the other ones are going to use, and this is a problem because we need to make sure that we don't corrupt the registers of the other. So to get around this, MIPS has a convention on who saves which registers. And when you save a register, you put it and you store the value somewhere else so that you can use it, and then when you're done, you can restore it. So this convention is divided between the callee and the caller, and if we follow this convention, any caller can call any callee. It makes sure that you'll never overwrite registers the other person uses without saving them first. And the way to do this is both the callee and the caller know what they need to save. So now let's talk about how we're going to decide what people save, and then we'll talk about how to save things. So what is the MIPS convention for saving things? So this convention is a contract or a protocol that everyone follows, and it specifies the correct usage of the registers and some naming conventions. So we're going to name them a little bit more specifically than just R1, R2, and R3, and we're going to use that naming to make it clearer what our code is doing. This is established as part of the architecture. What it means is that when you talk about MIPS, everybody knows that you're using these particular conventions. And it's used by all the compilers, all the programs, and all the libraries, and this allows you to get a compatibility. It means that you can call procedures in one library from another library, and you're sure you won't write over each other's registers because everybody's following the same convention. So here it is. The callee saves the following registers if it uses them: S0 through S7. So S just means saved. So we're going to take some of our registers and we're going to name them S0 through S7, and the convention says that if the callee uses them, it must save them. There are some other registers that also need to be saved: stack pointer, frame pointer, and the return address. And we'll talk about what those are a little bit later on. The caller needs to save anything else it uses. So if the caller uses other registers that aren't in those registers there, it's responsible for saving them. This divides it up very nicely and makes it clear what the callee needs to save and what the caller needs to save. So here's a question. What are these registers, S0 through S8, SP, FP, and RA? Well, they're just standard names for a bunch of other registers. In particular, S0 through S8 are R16 through R23, and R29 through R31 are SP, FP, and RA. So we'll take a look at that in just a minute. So here are the conventions for registers and their names. You can see we have all 32 registers listed here, and they all have names. And we'll take a look at what they are. So these are the S and the SP, FP, and RA registers. These are the ones that the callee has to save. So if the callee is using any of these registers, it has to save them. These are the other registers that the caller has to save. So these are named T for temporary. So if the caller uses any of these registers, it's responsible for saving them. And then we have a few other special registers: V0, V1, and A0 through A3. These are where we store arguments and values. So the arguments are the inputs to the parameter, or to the procedure that we're calling, and the values are the return results. So this is how we make sure that the procedure knows where to get its inputs and where to put its outputs. So how do we do a procedure call? We've talked about where you store data and whether the callee or the caller needs to make sure it doesn't overwrite registers by saving them, but how do we actually get to the procedure call? So to do that, we need to transfer control to the callee, and we do that through a JAL instruction. This is jump and link. So jump and link procedure address is going to do two important things. The first is it's going to jump to that label procedure address, and the second one is it's going to take the return address and store it in RA. So that is, it's going to take the address of the instruction after the jump and link and store it in register RA. RA stands for return address. When we're done with the procedure and we want to return to the caller, we need to jump back to the address stored in RA, and we do that with jump return, JR, and we jump return to the address we just stored. So this is why we need to restore the return address. After we're done, we jump back to that return address. So let's take a look at the register convention for procedure calling. We have 4 argument registers, A0 through A3, and this is where we pass in parameters to the procedure, so the procedure knows where to find its inputs. We have two value registers, V0 and V1, for returning the results. We have the RA register. This is the return address. This is saved when we jump into the procedure, and it tells the procedure where to jump back to in the caller.